right, this is Antiderivatives. This is coming from the Educo Soft Book, Chapter 4.9. Antiderivative is the reverse of differentiation. For instance, if we had 1/3 or f of x equals to 1/3 x cubed, the derivative of that would be x squared. Well, the antiderivative is pretty much going back to its original state. So the original state or the antiderivative of this would essentially be 1/3 x cubed, right? But we'll go into more detail in a minute. An antiderivative without adding or subtraction of a constant is called a particular antiderivative. A particular antiderivative with a constant c is called a general antiderivative. A particular antiderivative pretty much does not have the constant c added onto it. If we are talking about our 6 trigonometric functions, we have several of those for the antiderivatives, and we're going to give those to you in the general form. The antiderivative of sine x is negative cosine x plus c. The antiderivative of cosine x is sine x plus c. The antiderivative of secant squared x is just going to be plain tan x plus c. The antiderivative of cosecant squared x is going to be the negative cotangent x plus c. Secant x, tan x, antiderivative would be secant x plus c. And cosecant cotangent x, the antiderivative would be negative cosecant x plus c. In the general form of antiderivatives, since we are doing the opposite, the antiderivative is actually adding the exponent, right? And then adding the exponent on the top and the bottom. So, for instance, this has no variable. So we would have this as, let me use a different color. We would have this as 2 to the x, since it has no variable or exponents, of 0 plus 1 divided by 0 plus 1, if I'm using this formula, plus c. Well, anything plus 1, 0 plus 1 is just 1, and then 0 plus 1 is 1, so my answer would just be 2x plus c as my antiderivative. The way that I remember, if I have a constant by itself, the antiderivative is just going to be with a variable plus c. So in other words, the antiderivative of 8 would just be 8x plus c. It is a very simple format, okay? But if we get a little bit more intricate, then we have 4x cubed plus 8x plus 10. You do each term for your antiderivative. So this would be 4x cubed plus 1 divided by, what was my exponent? 3 plus 1, right? Plus, you do the same thing for 8x. 8x to the, what's the exponent of x to the, technically what? First power of 1 plus 1 divided by 1 plus 1. Plus, I have a full constant number here, so this would be plus 10x, okay? I add my exponents, and this will give me 4x to the 4th divided by 4 plus 8x squared divided by 2 plus my 10x, since I've already done the antiderivative. Simplify as best as you can. Well, 4 divided by 4 is just 1, so that'll leave me with x to the 4th plus 2 divided by 8 will be 4, so that'll be 4x squared, and then plus my 10x. And now I have found my antiderivative. You might get some intricate cases where you have an actual square root. So maybe you should write it in terms of what? 2x to the 1/2, right? And it will be a positive 1/2 because it is on the top of the numerator. So we have 16x cubed plus 1 over 3 plus 1 minus 2x to the 1/2, and you always keep it in terms of fractions. So then if I'm supposed to add this by 1, the real fraction of that would be 2 over 2 divided by 1/2 plus 2 over 2. Since I have my constant here, that would just simply be 11x. So 16x to the 4th divided by 3 plus 1 is 4 minus 2x to the well, what does that give me? 1 plus 2 is 3, so that'll be 3 halves, and 3 halves is on the bottom here, plus 11x. I cannot leave my fractions, so I must simplify. 4 goes into 16 4 times, and that'll be 4x to the 4th, right? Minus, we never divide fractions, we always multiply by its reciprocal. So this should be 2 over 1 times, we flip this one, right? So 2 comes at the top, and 3 goes to the bottom. X to the 3 halves, plus 11x, okay? So 2 times 2 is going to give me 4, so I'm going to rewrite it one last time. 4x to the 4th minus 4 over 3x to the 3 halves plus 11x. And the only thing that I forgot to add on both of these is the plus c, because majority of the time we want to put it into the general form. Okay, this is part 1 of antiderivatives. I have one more after this. Thank you.